coordinates minus 1, 5 and 2, 3, we still want to find the equation. Now you're saying to me, okay, from the formula booklet, this bit gives us 1 coordinate and 2 coordinate. So can't we just use that? Okay, yes you can if you want, because then you can calculate the gradient and you can then go on to using this formula if you want. Okay, but at the moment we don't actually have a gradient, so I can't just substitute that in. Now what I've said is that you're happy that m, the gradient, is equal to y2 minus y1 over x2 minus x1. Like we said yesterday, it's just the change in y over the change in x. Yeah. So you're happy with that as a single formula. Yes? Good. And that's given to you in your formula booklet, so you don't even have to learn that one. You're happy with what we just did, whereby we said we don't have a second coordinate, so we'll just leave this as x and y. Now here's the magic bit, okay? If this is equal to m, and this is equal to m, are you happy that I could get rid of that bit, and that m is still going to be equal to that? Sorry, I should have left that one in there. Yeah? M is still equal to this, and m is still equal to this, yeah? Happy with that? Yeah? Okay. Well, if they're both equal to m, they must therefore be equal to each other, because they're both the same as m. Magic! And what you've just done is derived a slightly new formula, not given to you, but based on what is given to you and what we learned about the fact that if we don't have a second coordinate, we can just drop a 2 from the y2 and the x2. And what you've got here is we're going to be able to find an equation because we've got the x and the y. Remember we said that if we want an equation, it's got to have the letters x and y in there. Well, that's where they come from here. We need one coordinate for x1 and y1, which we're going to use there and here. And then we need a second coordinate for x and y. There's my first coordinate, there's my second coordinate. Happy? Okay, from here, it's quite straightforward. Let me just move those a little bit closer. They look a little bit separated.
If we've got 2 coordinates, why aren't we just using the first formula?
This one here?
Yeah.
Can do. I'll show you that way in a second. Okay, it's just a bit more long-winded. Alright. Here, all I'm going to do is substitute in. Well, if I'm making this my x1 value and my y1 value, this is my x2 value and my y2 value. Substituting in, what's y2?
3.
3. Minus y1?
5.
Over x2 is 2. Minus x1? Minus 1. So 2 minus minus 1. Okay, equals y just stays as it is. y1 was that 5. X stays as it is. x1 is that minus 1. Happy with the substitution in there, yeah? Now, because this bit is equal to m, now that I solve this, I'm actually going to be working out the gradient. 3 minus 5, excuse me, gives me minus 2. 2 minus minus 1, double negative means I add to give me 3. So my gradient, therefore, has been worked out for me. Okay, minus 2/3. Y minus 5, can't simplify that at all. X double negative with the 1 becomes x plus 1. Happy so far? Okay. Now what we've got essentially is using this formula. We've got the gradient, which we know is minus 2/3, minus 2/3, we know it's a negative gradient. We've got the x and the y, and we've got essentially one coordinate in there because we've combined these 2 coordinates to work out what the gradient is. So that's why I'm saying if we can use this, then it basically combines everything into one, rather than using this and then using that. Okay, what we've done is just combine them together. From here, you're looking at it going, right, okay, I've got this fraction line, which means divide. Aha, easy. We can remove that divide by doing the opposite, which is times by 3. And if I multiply this side by 3, I'm actually only affecting the numerator. So if I break it down one step at a time, that's going to give me negative 2, because these two cancel out, which is equal to, remember, easiest way, safest way to start off with is just to show brackets, over x plus 1. You think, brilliant, I had a fraction, I've now made it a whole number, still got a fraction here. Let's eliminate that one by timesing by x plus 1. And whatever I do to that side, I have to do to the other side of my equation. So now, running out of space, he moves up here. Which gives me, again, easiest way to multiply is to put it into the brackets, which equals 3 lots of y minus the 5. Okay, from here we've got a very simple equation with brackets, with x appearing on both sides. Expand the brackets, minus 2x minus 2 equals, expand the brackets, 3y minus 15. Happy so far?
Yeah.
Yeah. What we want to get to is maybe this form, y equals mx plus c. So I'm going to eliminate the minus 15 here by adding 15 to both sides. Gives me minus 2x plus 13 equals 3y. I need to get it just down to y. So how do I eliminate that? Divide by 3. But remember, I've got to do it to every single term. What's the easiest way of showing divide by 3? Because I don't know what 13 divided by 3 is off the top of my head. Well, I do. That's just for the camera. I don't want people on the internet thinking I'm thinking. Move on quickly. What's the easiest way of showing a divide?
It's 13 over 3.
Yeah, as a fraction. So make it minus 2 over 3x plus 13 over 3 equals y. Okay, what's my gradient here? Minus 2/3, because it's the amount of x. What's my y-intercept? 13 over 3. Boom! Easy.
Why didn't you simplify minus 2 equals 3 brackets?
Why did I what, sorry?
Why didn't you simplify? Yeah, down, yeah. Yeah. Above? Yeah. No.
But you said down, you said up above.
3 brackets y minus 5. Why didn't you simplify that there?
I could have done. I just simplified it here instead. I was being lazy. Couldn't be bothered. It's Thursday afternoon.
Okay.
Almost.
Morning.
In parts of the world. Okay, you can expand it here, you can expand it here, it doesn't really matter. You expand it somewhere, okay? It's entirely up to you. Any more questions?